Hi everyone! In today's video I will be going over the 8A test review. First thing I want to draw your attention to, flip over to the answer key on the back page. There is one small error we need to fix. Number 8, this should be x minus 5 over 2. So just make sure you fix that. I've already done the whole study guide. That's the only mistake I was able to find. Hopefully I don't find any others in this video. Alright, let's go over these. Now you will want to have your green sheet handy for factoring help. If you like, reminder, you are not allowed to use this on the test, so keep that in mind. You'd like to use it less and less, but if you're still struggling with your factoring, it is a good resource to use. Simplify, remember to factor when necessary. Number 1. 120 x cubed y over 25 x y to the 5th. So on this one there's no factoring, we just have numbers and letters. So we're going to look at reducing and working with exponent rules, and that's about it. There's really no work to be done here besides the canceling part, so I'm going to jump right into that. So looking at the numbers, I've got the 120 and the 25. I can simplify those down. Unfortunately, I don't have a calculator on me, but remember the calculator can reduce fractions for you with that ABC button. So if you have questions about that, feel free to come talk to me. All right, 120 and 25. One factor that should jump out at you is 5, and that is the factor we need. These are both divisible by 5. When we divide them by 5, so we're dividing by 5 here, just for clarification, the 25 turns into a 5, and the 120 turns into a 24. I'm going to mark out the divided by 5 now so it's not confusing. All right, now the exponents. I have x cubed on top, and then remember this on the bottom is like an x to the first. So we got 3 on top, 1 on bottom. We'll subtract on the top because that's where the bigger exponent is, so minus 1. So now we can get rid of the x entirely. And then we got y, again that's to the first on top, and then y to the 5th on bottom. So again we will subtract, but this time we'll subtract on the bottom because that's where the bigger number is. We do that to avoid a negative exponent. Now we can cancel out the y. This looks a bit messy, but we'll be able to create a nice answer from here. So my final answer for number 1, on top I've got the 24. And then the x, that's 3 minus 1, so this becomes x squared. On the bottom, I have the 5. And then y to the 5 minus 1 turns it into a 4. So 24x squared, 5y to the 4th is our answer. All right, number 2. X squared plus 9x plus 20 over 2x plus 8. This one will involve a bit of factoring. So, on the top, we've got the x squared plus 9x plus 20. That is a trinomial. So we can factor that. All we need for that is a simple ACB chart. 3 terms, no number in front, so that's how I know. Now AC, A is 1, so we're just going to look at C, which is 20. B is 9. Now 20 has a few pairs of factors. One pair that should jump to the front of your mind is 4 and 5, and that is the pair we need because 4 plus 5 gives you 9. So, can write this as factors. We have x plus 4 and x plus 5. They are both positive. And then on the bottom we have 2x plus 8. Hopefully you notice these are both divisible by 2, so that means we have a GCF here. So we can divide both of these by 2. The 2 gets pulled out, and what's left ends up in parentheses. So the 2's are going to cancel, leaving us with x, plus 8 divided by 2 is 4. So then, going back to our new fraction, we have 2 times x plus 4 on the bottom. Everything has been fully broken down. All we have left to do is cancel. On the top and the bottom, we have an x plus 4, so that's going to be gone. And then we have x plus 5 on top and 2 on bottom. Those can't cancel, so those are going to be in the final answer. So we have x plus 5 over 2. And that is our final answer. Number 3, x squared minus 4 on top, x squared plus 5x plus 6. These are just very quick factoring problems to kind of warm you up. So hopefully you recognize them. X squared minus 4, you should be in the habit by now, hopefully, of recognizing this is a difference of squares. X squared can always be square rooted. It's got a square on it. And then 4 is a perfect square. Its square root is 2. So when we set up our factors, we've got 2 of them. Square root of x squared is x, so that's going to go in the front. Square root of 4 is 2, that's going to go in the back. And you need one with a plus and one with a minus. On the bottom, x squared plus 5x plus 6, 3 terms, so that's a trinomial. No number in front. So again, we only need a nice ACB chart. A is 1, so we look at C, which is 6, and B is 5. Now be careful with this one. Some students tend to mess up with the 5s and the 6, so really do think through the factors. So 6, we've got 1 and 6, and 2 and 3. Now the reason I say be careful is because both of these can give you a 5, but it just depends on your circumstance. We want a positive 6 here. So positive 2 and positive 3 will give me positive 5. To get 5 from 6 and 1, I'm going to have to do subtraction, and that will not give me a positive 6 when multiplied. So 2 and 3 are the factors I need this time. X plus 2 and x plus 3 are my new factors, so we'll go on the bottom. From here, it's just canceling things. I have an x plus 2 on top and bottom, so it's going to cancel out. X minus 2 on top, x plus 3 on bottom, can't do anything with that, so that is my answer. Number 4. X squared minus x minus 12, x squared minus 2x minus 8. These are both 3 terms, so trinomials, and they have no number in front. So I just need an ACB chart for each one, and I will be able to get my answer. So x squared minus x minus 12, I'll do that one first. ACB chart. A is 1, so we look at C, which is negative 12. B is negative 1. 12 has several pairs of factors. The one that we need is the pair 3 and 4. Reminder, if you can't come up with the factors right away, believe me, that is something that takes a lot of practice. So if you're not there yet, it's fine. Write them down. A lot of students try to think them over in their heads, and sometimes they think of the right pair, but gloss right over them. If you write it down, you're more likely to notice it. So, if you needed to make the full list, it would be 3 and 4, 1 and 12, 2 and 6. And then from there you can narrow down which pair you need. We want 3 and 4 because they're only 1 apart, and when we subtract, we can absolutely get a 1. Now we need negative 1, so 4 has to have the negative sign this time. 3 minus 4 is negative 1. And then make sure that the multiplication still works. 3 times negative 4 is negative 12. So these are the factors I need for the top of my fraction. So we have x plus 3 x minus 4 on the top. And then I'm just going to do the ACB chart under here. Just kind of do that, if you will, since I'm running out of space. All right, ACB chart. A is 1, so again we look at C, that's -8. B is -2. 8 has two pairs of factors, 1 and 8, 2 and 4. 2 and 4 can absolutely give us a -2. We're going to have to do some subtraction. Since we want a -2, 4 is going to be negative. 4 determines what sign the answer has. 2 minus 4 is -2, which is exactly what we needed. So we have x plus 2, x minus 4. Now I cancel. X plus 3 on top, I do not have an x plus 3 on bottom. X minus 4 on top and bottom, we can cancel. So we're left with x plus 3 over x plus 2. All right, number 5. X squared plus 3x minus 40, 2x squared minus 10x. Now on top here, we have a trinomial. It's 3 terms, no number in front. So once again, we just need an ACB chart. And I'm going to use this space here for the GCF. So I'm actually going to come down here to do that. So x squared plus 3x minus 40. And I could have worked with the space above it too. It's just wherever you have space on the page, if you need space to do your work. ACB. A is 1, C is -40, B is 3. Now 40 has quite a few pairs of factors. We got some of the obvious ones, 1 and 40, and then it's even, so 2 and 20. One pairing that you might think of kind of often is 8 and 5. That is the pair that we need because they are 3 apart, and that will give us a 3. Now that will be accomplished with subtraction. We want a positive 3, so 8 has to be positive. So 5 will get the negative. 8 minus 5, or -5 plus 8, is positive 3. And then when I multiply, I still get a -40. So on the top, I have x minus 5, x plus 8. On the bottom, I've already kind of given away the fact this is a GCF. We've got 2 and 10, so you can divide both of those by 2. And then they both have x terms, and the smallest one is the x. So I'm going to pull out just x. So 2x is my GCF. Do not forget to take it out and put it on the outside. A lot of students like to forget the GCF. If you forget the GCF, your answer will be wrong. All right, let's cancel a little bit. The 2's are going to cancel. X squared on the bottom, just x squared on the top, only 1 on the bottom. So when I subtract the exponents, I'll just have an x left over. Minus 10 divided by 2 is 5. And then these x's will cancel. So 2x times x minus 5. I fully factored this fraction. Now I can cancel. X minus 5 on top and bottom, that's going to cancel. X plus 8 on top, I don't have one of those on bottom. So I'm done canceling, and I'll just make my answer. X plus 8 over 2x. Next problem, number 6. Two x squared plus 11x plus 12 over x squared plus 9x plus 20. On the top, this is a trinomial, and we do have a number in front. Reminder, always check for the GCF when you see a number in front for 2 reasons. 1, if there's a GCF, you can pull it out and make this an easier problem to solve. 2, you kind of have to. If you don't pull out the GCF, in the majority of cases, I've seen a few where it's still worked out, but not many. In the majority of cases, if you don't catch the GCF and then you slide and divide, your answer will be incorrect because the slide and divide gets rid of the GCF and you don't realize it. So you do have to check for this. Plus, on top of that, it does make the problem easier. If you can get rid of that number on the front, then you don't have to slide and divide. And we all know that just doing the ACB chart is easier. Now, unfortunately, I can't take out the 2 because the middle number 11 is odd. If I take out the 2, I'm going to get a fraction, or even worse, a decimal, so not ideal. I have to do slide and divide here. Thankfully, on the bottom, I just need an ACB chart. So I'm going to leave myself a little space down here to do that ACB chart. I'm going to create a little space there. This is where I'm going to do the slide and divide. So we have 2x squared plus 11x plus 12. Slide that 2 over. We have x squared plus 11x plus 24. And then we need to factor this. This will take an ACB chart. I'm going to go ahead and set up my factors. So we've already done the AC step. That's how we got the 24. So 24. And the B is 11. 24 has several pairs of factors. 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 3 and 8 are the pair I need. If you're thinking about it, 3 and 8 do give you 11 when they're both positive. So that is what I need. And then 3 times 8 is positive 24, which is also what I need. So these are perfect. X plus 3, x plus 8. Now remember, we're doing slide, so we have to divide. Slide and divide. We slide in the beginning, we divide in the end. Come back and divide by that A, which was 2. From here, we simplify. X plus 3 over 2. This does not divide, so I'm going to slide that 2 in front of the x. 2x plus 3. 8 does divide by 2, it's 4, so x plus 4 is the other factor. So 2x plus 3, and then x plus 4 on top. Now I'm going to come back up here and do my little ACB chart to do my trinomial on the bottom. A is 1, C is 20, so 20. B is 9. And I believe we've already done this exact pairing. We have. We had this exact same trinomial in problem number 2, x squared plus 9x plus 20. So if this felt familiar, it is. It's going to break down the exact same way. So our factors, again, are 4 and 5. 4 times 5 is 20. 4 plus 5 is 9. So it's x plus 4, x plus 5. There are actually a couple that are going to repeat throughout the study guide, like that. Now we cancel. I always like to just go on the top and see what I have on the bottom. 2x plus 3 on top. I do not have that on bottom. X plus 4 on top and bottom. That cancels. Final answer. 2x plus 3 over x plus 5. All right, there was the first 6. Now those were just problems where we handed you a fraction and we're asking you to simplify. So factor it and cancel things out. The next section you have to perform an operation first. So you're either going to multiply or divide some fractions, and then you're going to factor and cancel. So it has an extra step to it. Reminder, anytime you have an expression, and that's all of these, where you have like a bunch of terms and they're put together by adding or subtracting. When you quote-unquote multiply them, you're not going to actually FOIL or distribute. That makes the problem more complicated, and we don't want that. We want to do the opposite. We want to break it down and factor it. So when I say multiply, you're actually just going to collect the terms and put them together, and then use parentheses to help separate them. So number 7, that's what I'm going to do first. To make sure you do just a quick look at what symbol is being given to you. As you can see, they're kind of small here. If it's multiply, you can jump straight in. If it's divide, remember you have to keep, change, flip before you can do anything in the problem. All right, this is multiply, so I don't have to worry about anything. I'm going to put these all in parentheses. Remember, we also do this to avoid canceling anything that we are not allowed to cancel. If you have something in parentheses, you have to have the exact same thing in parentheses to cancel out with something else. All right, so we are going to quote multiply, which really we're just going to put them together into one fraction. So on the top we have 5n plus 15 and 2n plus 4 over 4n plus 8 times 3n plus 9. 5n plus 15, this is a GCF problem. I'm going to do the work over here. So 5 and 15, you can divide both of them by 5. So 5 is my GCF. 5 comes out, it doesn't disappear. So the 5s are going to cancel, leaving just n plus 15 over 5, that's 3. Now thinking ahead, since I do have not as much space on the study guide as I would like, I am going to take advantage of this space to do the GCF on the bottom, so I do want to leave a little space under here. 5 times n plus 3. 2n plus 4, another GCF problem. Hopefully you noticed it. You can divide both of these by 2. And again, I can notice GCF problems just by looking at the two terms involved and asking, is there something that they have in common? In this case, it's a 2. Remember, 2 comes out, it does not disappear. 2's cancel, we're left with n plus 4 divided by 2 is 2. So it's 2 times n plus 2. Now on the bottom, I could take advantage of this space I left myself. 4n plus 8, this is another GCF. 4 and 8, they have 4 in common. And 2, but we want the biggest one. Now I can't show as much work as I just did a moment ago, but hopefully you're getting the idea. Don't forget the 4 comes out, it does not disappear. And then 4 divided by 4, it's going to cancel, so we're left with just n plus 8 divided by 4 is 2. 3n plus 9, another GCF problem. 3 and 9, they can both be divided by 3. 3 comes out. The 3's cancel here, so we have n plus 9 divided by 3 is 3. All right, let's start canceling with the parentheses. N plus 3 on top, n plus 3 on bottom, those will cancel. N plus 2 on top, n plus 2 on bottom, those will cancel. Now, don't forget, this whole time, all of this is multiplication. So this is 5 times 2 on top, not 5 plus 2. And if you're not convinced, you can put these in parentheses to further just convince you. This is all multiplication. So I recommend you multiply, and then we can reduce. So obviously, all of these canceled out, so we just have the numbers left. 5 times 2 is 10. 4 times 3 is 12. And then we really should reduce that down. 10 over 12. Again, ask yourself what they have in common. They are both even. So we can divide both of these by 2 to reduce. And we are left with 5/6 as our final answer. So that was just all GCF on repeat. Number 8. X squared minus x minus 12 over x minus 4. Pay attention, divided by 2x plus 6 over x minus 5. This one isn't too heavy on the factoring. Now don't forget, you have to keep, change, flip. Make sure you're paying attention to if you have a division sign, you have to do that. If you don't notice it, again, it will mess up your problem. So let's rewrite the problem correctly. Keep the first fraction the same. X squared minus x minus 12 over x minus 4. Change division to multiplication. Times x minus 5 over 2x plus 6. From here we can multiply. So again, when I say that, I mean just put the terms together. Don't make it super complicated. Put them together into one fraction. X squared minus x minus 12 times x minus 5 over x minus 4 times 2x plus 6. Alright, we only have two things to simplify here. On the top, we've got that x squared minus x minus 12. X squared minus x minus 12. It's a trinomial, 3 terms, no number in front, so we just need an ACB chart. A is 1, C is negative 12, B is negative 1. Let's go with 3 and 4. They are 1 apart. To get a negative 1, the 4 has to have the negative on it. 3 times negative 4 is negative 12. 3 minus 4 is negative 1, which is what we needed. So, my factors for that trinomial: x plus 3, x minus 4. Now I can bring down the x minus 5. There's nothing to do with it. And I am trying to keep in mind that I don't have a lot of space. So that's why I'm writing a little extra small here. On the bottom, I've got x minus 4. 2x plus 6. I hope you caught. This is a GCF problem. Again, look for things. What do they have in common? They don't both have an x, so I can't pull out an x, but they are both even, so I can divide by 2. 2 comes out, it doesn't disappear. 2's cancel, we have x plus 6 divided by 2 is 3. So now we have 2 times x plus 3. Now we can cancel. X plus 3 on top and x plus 3 on bottom, those cancel out. X minus 4 on top, x minus 4 on bottom, those can cancel. X minus 5 on top, but we do not have 1 on bottom, so we are done canceling. So come over one more time and rewrite for your final answer. X minus 5 over 2. And that is it. Number 9. X plus 3 over 10x plus 2 times, so we're good, we don't have to do keep, change, flip. X plus 2 over x squared plus 4x plus 3. So first thing, we're going to multiply, which means just put them together on the same fraction. Bring in those parentheses so we don't cancel anything that we are not supposed to. X plus 3 times x plus 2 on the top. On the bottom, we have 10x plus 20 times x squared plus 4x plus 3. Factoring. The top, we can't do anything, so just bring it over. X plus 3 times x plus 2. On the bottom, we can factor. 10x and 20. Again, look for those similarities. This is not a trinomial, so we know we're not going to use an ACB chart. These both can definitely be divided by 2 for sure, but again, we're looking for the greatest common factor. They both end in 0, so 10, and that's the biggest number I can divide 10 by. 10 has to be the GCF here. So divide both of them by 10. Again, 10 comes out, it does not disappear. 10's cancel, so we have x plus 20 over 10 is 2. So now we're going to put that in our new fraction. 10 times x plus 2. And now the trinomial. X squared plus 4x plus 3. ACB chart. A is 1, so we look at C, which is 3. B is 4. Make sure you put them in the right place. This is an easy thing to factor, but the biggest mistake I see here is students flip-flopping the numbers, and then obviously that will be wrong. 3 only has one pair of factors, 1 and 3. And 1 plus 3 is 4. So that was pretty easy. X plus 1, X plus 3. Everything is factored, so now we can cancel. X plus 3 on top, X plus 3 on bottom. Let's cancel. X plus 2 on top and bottom. Cancel. Everything has been canceled out on top, so I am done. Put the rest of it into your answer. Now reminder, when the whole top cancels, we don't suddenly take what's left out of the fraction and make it its own answer. This is still on the bottom of the fraction. So this is 10 times x plus 1 on bottom. If there's nothing left over on top, you put a 1 in there. Remember, this is division. When these things cancel, it doesn't become 0, it becomes a 1. On top of that, you can just think of the 1 as a placeholder, if that makes more sense to you. So 1 over 10 times x plus 1. Number 10. Three x plus 6 over x squared minus 9 divided by, so that means keep, change, flip. This time I'll just say KCF for short. So I'm not even going to bother rereading the problem because I'm going to have to change it. Alright, so let's rewrite. We have 3x plus 6 over x squared minus 9. Keep this the same. Change division to multiplication. Flip the second fraction. So it becomes 4x plus 12 over 6x squared plus 12x. And the factoring on this one is actually not that bad. So, first off, we want to put this into a single fraction. And again, go ahead and introduce those parentheses early so we don't cancel anything that we are not allowed to cancel. We have 3x plus 6, 4x plus 12, over x squared minus 9 times 6x squared plus 12x. Alright, one term at a time. 3x plus 6. Hopefully you notice there's a 3 and a 6. They both have 3 in common. That means I can pull it out. GCF. So I'm going to divide both of those by 3. And I'm trying to figure out how much space I have. Not a lot. So I'm going to show a little less work on this problem for that reason. My apologies there. Yeah. Okay, so you pull out the 3. The 3's are going to cancel, so we're left with x plus 6 divided by 3 is 2. 4x plus 12. Once again, look for if they have something in common. Always look for a GCF first. It seems like that is it seems to be the theme on this study guide. There's a lot of GCF, so always look for it. And when it's not a trinomial, it narrows your options down very quickly. They can both be divided by 4, so let's take out 4. Reminder, 4 doesn't disappear, it just comes out. 4's cancel, we are left with x plus 12 divided by 4 is 3. Alright, x squared minus 9. Hopefully you recognize that. It's two terms being subtracted. 9 is a perfect square, so this is a difference of squares. Square root the front, square root the back. 2 factors, not 1. Square root of x squared is x. Square root of 9 is 3. And then one of them gets a plus, the other gets a minus. and we are almost done here. 6x squared plus 12x. Six x squared plus 12x, I'm going to squeeze this work into here because I do need this space over here, unfortunately. Nah, I'll make it work. So 6x squared plus 12x. Once again, we've got two terms, not a trinomial, so let's look for a GCF because they're not being subtracted like the difference of squares was. They do have a GCF. 6 goes into 6 and 12, so divide by 6. On top of that, they both have an x term, so we can pull out x. And it will just be 1x because that's the smallest term. So I'm going to pull out 6x. What's left over? So the 6's cancel. We have x squared over x to the first. If I subtract, I'm just going to have x left. Plus 12 over 6, that is 2. And these x's are going to cancel. Okay, I managed to fit it all in there. So this is completely broken down, and now we can start canceling. I'm going to handle the numbers separately, so I'm not going to do anything yet with that. X plus 2 on top and bottom, it cancels. X plus 3 on top and bottom, it cancels. That's all I can do for the moment, so I'm going to write what I would think would be my final answer, but it's not. Make sure you're careful with that. 3 times 4, that's 12. And then I've got 6x times x minus 3. Now, before you box your answer and think you're done, especially when you have to multiply things before when you get to your final answer, there's a chance you got to take a second look and make sure you're not forgetting anything. I've got a 12 on top and a 6 on bottom. I am not done. 12 and 6 you can reduce for sure. Divide them both by 6. 12 turns into a 2 when you divide it by 6. 6 is going to disappear because 6 divided by itself is 1. So I have to rewrite this answer one more time. This is just a 2 on top now. And then x times x minus 3. So it's a little tight, but I made it work. Now, if you're more comfortable not showing as much work as I'm showing on the page, then you're going to save yourself even more space. But make sure you do whatever you need to do to get the problem right. So if you need to take up more space, then that's fine. All right, that was the front side. Next page. We are actually almost done here. Just a few more problems and then some very quick problems at the bottom. Simplify each complex fraction. So remember, that's where we have a fraction over a fraction. These are actually just division problems disguised as complicated fractions. So remember, you look for the dividing line. They try to make it obvious, especially when we are able to type these problems. The computer tries to make it obvious. The dividing line, it's usually in the center if it's two fractions. And notice it's slightly longer and darker than the other fraction lines, so you can tell. So this is where I'm going to divide. Now here's the tedious part. I strongly recommend you rewrite the problem twice. You first write it as just a normal division problem. So to give myself the most space, I'm going to rewrite it up here. So we have x squared minus 25 over x plus 6 divided by, and then we're not changing anything yet, so just write it as is. 2x minus 10 over x squared, I'll go ahead and put parentheses around it, plus 5x minus 6. Now, again, we've got division here, so that means keep, change, flip. So I've got one more step before I can start solving. So again, anytime you get division, you need to rewrite it the right way with keep, change, flip. So we're going to keep the first fraction the same. x squared minus 25 over x plus 6. Change division to multiplication, flip the second fraction. X squared plus 5x minus 6 over 2x minus 10. Now that this is multiplication, we can start simplifying and canceling like we have been this whole time. So, change this to one big fraction. X squared minus 25. Actually, let me backtrack. Just for space, if you remember, I do like to start on the left side over here, just to give myself as much space to work with as possible. So that's what I'm going to do. X squared minus 25. X squared plus 5x minus 6. X plus 6 on bottom. 2x minus 10 as well. Not a ton of factoring here to do. Okay. On the top, first and foremost, x squared minus 25. Two terms, there's subtraction, and 25 is a perfect square. Its square root is 5. So I can square root the front and square root the back. This is a difference of squares. We have x's in the front. Square root of 25 is 5, so 5's go in the back. One gets a plus, the other gets a minus. X squared plus 5x minus 6. That's a trinomial. It has three terms. No number in the front. That's the best kind. So all we need is an ACB chart. Now here's where I say to be extra careful with the 5 and the 6, and you'll see why. So A is 1, so C is negative 6. B is 5. Again, students see that 5 and they immediately jump at 2 and 3. 2 and 3 will not work here because 2 plus 3 is 5, but 2 times 3 is not negative 6, it's positive. This is where we need 1 and 6. To get 5, we need to subtract, and 1 has to have the negative on it. So 6 minus 1 is 5, but also check the multiplication. 6 times negative 1 is negative 6. So be very careful there. So my factors are x minus 1, x plus 6. On the bottom, we have x plus 6. 2x minus 10. Hopefully you are starting to pick up on these things. There is subtraction here, but a couple things. 10 is not a perfect square. And x does not have a 2 on it. It's not squared. So this is not a difference of squares. That means it has to be GCF. And we can divide both of these by 2. So it is a GCF. So pull out the 2. What's left inside? The 2's cancel, so we have x. Minus 10 over 2 is 5. We have factored everything, so now we can cancel. X plus 5 on top, I don't have an x plus 5 on bottom. X minus 5 on top and bottom, it cancels. X minus 1 on top, I do not have one of those on bottom. X plus 6 on top and bottom. So we are left with x plus 5 times x minus 1 over, we just have a 2 on the bottom. Just going to flip this over, make sure I got the right answer. And I do. And by the way, some students think that these parentheses, when your answers have these sets of parentheses, they have to go in a certain order. They do not. As long as they are the correct numbers, that's all that matters. Number 12. Same process. We've got a big complex fraction here, so just identify where the dividing line is. When it's a fraction over a fraction, it's going to be kind of obvious, so that's nice. That's the point. So we're going to take 2 steps. Rewrite it as division and then keep, change, flip. X squared plus 4x over 6x squared divided by, we're not changing anything yet, 4x squared plus 16x over 12x to the 4th. Now we have division. So again, keep, change, flip. So rewrite it again. Keep the first fraction the same. X squared plus 4x over 6x squared. Go ahead and put parentheses around expressions. Change division to multiplication. Flip the second fraction. 12x to the 4th over 4x squared plus 16x. Now we multiply. That means we just collect all the terms and put them all together into one fraction. On the top, I'm going to put that 12x to the 4th in front. Remember, this is, we call it a monomial. That means that it is one term. So there's no pluses or minuses there. It's just one thing all together. It's a little easier to simplify when this is in the front. Then we'll put the expression after it. X squared plus 4x. On the bottom, we've got the 6x squared, which I do want that in front as well, just like with the 12x to the 4th. You can kind of see, hopefully now with them over each other, why I wanted them in front. And then 4x squared plus 16x. All right, let's go ahead and start simplifying. So x squared plus 4x, 2 terms, not a trinomial. So this is either a difference of squares or a GCF. They're being added, so it can't be a difference of squares, so we're going to look for a GCF. Notice they both have x in common. That means I can take it out. So I'm going to show a little less work here. Side note, I'm going to bring over the 12x to the 4th first. And then, if it makes more sense, you might want to put parentheses around this. If you don't, it's not a big deal. X is going to come out as the GCF. I'll go ahead and rewrite it over here. I have the space. So we have x times, we've got x squared over x to the 1st. So when I subtract, we are left with just x plus x's cancel out entirely over there. So x plus 4. So I recommend a parenthesis first and then put this in there. Visually, it would look weird if you didn't have this parenthesis between the x to the 4th and the x, but it's still okay to write it that way if that's how you wrote it. Okay. Now on the bottom, I have 6x squared, and then the 4x squared plus 16x. I can do some work here. 2 terms being added. This is another GCF. 4 and 16, you can divide both of those by 4. X squared and x, they both have x in common, so I'll take out x as well. So that's my GCF. Take out the 4x, and what's left over? 4's cancel. X squared over just an x. That leaves me 1x left. Plus 16 divided by 4 is 4. X's cancel. Again, I'm introducing another x term, so it might make more sense to put a parenthesis first before you write this in. 4x times x plus 4. Okay. And if it's even more helpful, you can even separate the 4x into its own set of parentheses. Again, it just depends on the person. And actually, I am going to do that, or else visually it might look weird to cancel out those x plus 4's. So let me change that real quick. Again, this is all multiplication, so I am allowed to section it off like that. All right, here's where we can start canceling some things. Okay, let's start at the very front. We've got 12 over 6. Now we know we can divide both of these by 6. 12 divided by 6 is 2. And then 6 divided by 6, well, that's 1, so that's gone. x to the 4th over x squared. So remember, when we're dividing, we actually subtract exponents. I'll subtract on the top since that's where the bigger one is. So 4 minus 2 up here. Cancel out the x squared now. Then I've got x over 4x. Now, just because the 4 is attached to that x doesn't mean I can't cancel the x's. I literally just did that over here. So cancel out x with the x. I've got one of each, so those just cancel out entirely. Lastly, I have x plus 4 over x plus 4. Those will cancel as well. All right, I am almost done. Let's come over and create our new answer. On the top, we now have a 2. X to the 4 minus 2, that becomes x squared. Canceled, canceled. On the bottom, canceled, canceled. Don't forget about this 4, it is not gone. Canceled, canceled. Now, don't forget to check your final answer. For the most part, we're able to cancel cleanly before we get to our final answer, but this was not one of those problems. So you just want to double check and make sure there's not anything else hanging around that we can simplify. 2 over 4, I hope you all see that and are like, oh hey, 2 is half of 4, so we can reduce. Divide both of these by 2. 2 cancels, 4 turns into a 2. So my final answer is x squared over 2. So sometimes when you have extra numbers that kind of come out as we factor, this extra step that's needed at the end will unfortunately happen. So don't just assume that the answer you end up with is the final answer. If you got extra numbers to work with, you might want to check and make sure you are done, because odds are you might not be. A lot of our other problems, like the one above, for instance, a lot of those things already canceled out, so there was no question. We were done with the problem. All right, last one of the big problems, and then we'll do some quick factoring problems. One more time, we have a complex fraction. That is a fraction divided by another fraction. Identify the division line. Write it twice. Write it as division and then keep, change, flip. This will help you avoid mistakes. X minus 4 over x squared plus 6x plus 9 divided by, we're not changing anything yet, x squared minus 2x minus 8 over 3 plus x. Now I'm going to make a note now. You will thank me later. 3 plus x. I'm going to come over to the side and do it. If I had my post-it notes handy, I would do it on there. You have 3 plus x. If I flip-flop these, they are both positive. So I can put the x first. It's a positive x. And then this is a positive 3. That is the same thing as x plus 3. Now, that might affect your ability to cancel things later, because we have not written anything like the 3 plus x. We've always had the x first. So you do want to make this change now, so you don't forget about it later. So I am going to go ahead and change that here. It's when you have negatives that you got to be careful when flipping terms around. But when everything's positive, everything switches places nicely. So, just a little thing to be aware of. Okay. Now, let's rewrite that with the keep, change, flip version. First fraction stays the same. We have x minus 4, x squared plus 6x plus 9. Keep that the same. Change division to multiplication. Flip the second fraction. X plus 3 over x squared minus 2x minus 8. Now we can quote-unquote multiply, so we're going to put them all together as one fraction. On the top, we've got x minus 4 times x plus 3. On the bottom, x squared plus 6x plus 9 times x squared minus 2x minus 8. Now we can start factoring and canceling. On the top, we have x minus 4 and x plus 3. We can't break these down even further, so these are good. Nothing we can do there. So I'll go ahead and start my new answer, and I'll bring those down. We have x minus 4 and x plus 3. X squared plus 6x plus 9. This is a trinomial. It has 3 terms, no number in front, so we just need an ACB chart. I'll come over here and write it. I've got plenty of space. A is 1, so we look at C, which is 9. B is 6. Now, if you think about it, 2 factors of 9 are 3 and 3. The other option's 1 and 9, and we can't get 6 from that. And we know 3 plus 3 is 6, so automatically that is what we need. X plus 3, you do need to write it twice. X squared minus 2x minus 8, again another ACB chart. A is 1, so we look at C, which is negative 8. B is negative 2. I'm fairly confident we've already seen this one on the study guide, but it could be wrong. 8, we've got 1 and 8, 2 and 4. To get 2, we will need to subtract with the 2 and the 4. We want negative 2 as our answer, so 4 has to be negative for that to work. 2 minus 4 is negative 2. 2 times negative 4 is negative 8. X plus 2, x minus 4. Everything is broken down, so now we can get to the fun part, which is canceling. X minus 4 on top, x minus 4 on bottom, they cancel. X plus 3 on top and bottom. Reminder, you can only cancel 1 with 1. You can't cancel this 1 with both of these. You have to make pairs. So I'm going to cancel 1 x plus 3 and another x plus 3, and that's it. This one's going to stay. Final answer. On the bottom, all we have left is x plus 3 and x plus 2. Reminder, when you have nothing on the top, it's a 1, not a 0. All right, we are done with the big factoring problems. Now at the bottom, we just have some factoring practice. Take a look at all 5 of these. You should notice they all have something in common. I'll give you just a moment to think about that. This first one is the dead giveaway of what they have in common. Some of these you may not recognize on the surface, but these are all difference of square problems. We are throwing these at you now because these would be considered more complicated, more advanced difference of squares problems. But you can have a number attached to that x squared as long as it is also a perfect square. 49, square root of 49 is 7. Square root of 81 is 9. Square root of 4 is 2. Square root of 9 is 3. Square root of 1 is 1. These are all difference of squares. So square root the front, square root the back, you do that on all of them. So I'll go ahead and fill in that now. Just make sure they are all perfect squares. If they're not perfect squares, then this trick we use will not work. X squared minus 49. Square root of x squared is just x. Square root of 49 is 7. One gets a plus, another gets a minus. 49x squared minus 1. Square root of 49x squared is 7x. Since they're attached, square root of 49 is 7, and then square root of x squared is x, so it's one thing. Square root of 1 is 1. One gets a plus, one gets a minus. These are definitely the kind of problems, once you've practiced them quite a few times, they become a lot more, like, you can kind of do them on autopilot, if you will. 81x squared minus 1. Square root of 81 is 9. And then x squared is attached to it, so it is 9x. And let me draw that line out further so you know we're taking the square root of all of it, not just the number. There you go. Square root of 1 is still 1. 1 gets a plus, 1 gets a minus. 2 more. 4x squared minus 49. Square root of 4x squared. Square root of 4 is 2. X squared will give us just x. So 2x. Square root of 49 is 7. 1 gets a plus, the other gets a minus. 1 more. 9x squared minus 4. Square root of 9 is 3. Square root of x squared is x. So 3x in the front. Square root of 4 is 2. 1 gets a plus, the other gets a minus. And there you have it. That is all of the problems in the study guide. I hope that this video was helpful. I tried to go through the problems a little more quickly than I would normally in person, but hopefully you're able to still follow along. If you need to, please feel free to go back, rewind, slow down the video, play it multiple times in certain parts, do what you need to do to make it make sense. If you're still struggling with this material after watching, feel free to reach out to me via email or come see me in person. Otherwise, I hope you have an awesome day. Bye!